Okay, so welcome back everybody. Today we're going to be doing continuation of last time's Python lesson. Just going to be wrapping stuff on that up, and then we're going to be going into an introduction to data science, which will be headed by Philip here on the call. So yeah, let's just get started. So last time we talked about how lists in Python are very cool. They have a lot of functionality that you don't really see in other languages. So I just want to go in a little more detail in regards to accessing elements. So we call this slicing in Python a list slicing. So it's basically a way to access certain portions of the list. And this is going to be the foundation of how you access data in data frames, which we will be getting to later on in the meeting. But essentially, just accessing the information that you want to see within your data structure, whether it be a list or a data frame or what have you. So here we have like a very simple example. We have a list in Python of length 6, and let's say we want to get the third, fourth, and fifth element from the list. The syntax for that would be the name of the. Wait, do I have an option to? 1 second here. There we go. So yeah, the syntax for this is that the name of the list followed by these square brackets, and then the indices, the start index and the end index. Sorry, the start index and end index of the portion of the list you want to get. So the first index is going to be inclusive, and the second one's going to be exclusive. So since I want indices 2, 3, and 4, I'm going to say start at index 2 and at index 5, and it'll return me back a 2, 3, 4, in which case are the elements bacon, tomato, and ham. So yeah. So this is just in general the syntax for it, like I said, initial end. There's also an option to set a step size or a jump size. So basically what that means is that if you want to get like every other element in the list instead of like each consecutive one, your index size would be 2. If you want every third element, your index jump would be 3, et cetera, et cetera. So that's just like, how many elements you want to skip on slicing the list. And that'll become clear from an example I show y'all. Anything else here? Nope. So let me just, before I get into NumPy, let me just demonstrate a little of what I just said here. So can anyone give me the names of some miners that are offered at UMD? And create a list that's full of miners. Math, true. This is valid. I am technically a math minor because I'm doing statistics minor, but I don't know. I don't know if Philip is too elitist to admit that.
You're not a math minor.
I'm not a math minor? Damn,
No,
that
you're not.
sucks.
You're a stats minor. It's different.
Okay, business analytics. All right, gatekeeper. Okay,
Mathematician. That's all we do.
gatekeep.
Yep.
Uh,
Like gatekeep, girl bug.
give me one more, just because like
Computer science actually is a minor.
that is true. Comp sci is also a minor, although I don't really see the point of that. I don't know.
Ed's doing that, so pick it up with him.
Nuclear engineering, is that actually a minor here? Damn, I was not aware of that. And computer engineering. Okay, cool. That seems like enough minors to include. So we have this list. So we're including all these elements here. They're all strings, so minors. And if I just print out what minors is, by the way, if you want to print out any element you have, you just say the name of the element in Colab or Jupyter.
Well, no, I'm saying only in Jupyter does that work.
Oh yeah, in Jupyter notebooks in general, I guess. And yeah, they'll just like, choop. gives back your data structure. So let's say I want to access the second through the second, third, fourth elements. In order to do that, I want indices 1, 2, and 3. So I'll just use the slicing syntax we used before. Start index, the end index was just like one more head of what you actually want because it's exclusive. And I go ahead and do that, and I get the I get the second, third, and fourth element from our list as desired. Um, if I only wanted the last two elements from our list, does anyone know what the syntax to do that would be? Okay, yeah, I got some answers. So I'm gonna test Ritik's a response here. That's basically colon -2, and that is interesting. So it actually returns not the last two, but the last two plus the first element. So it seems to be wrapping around.
Yeah, because you set the step size to -2. You did nothing for the first index, nothing for the last index, and then you said jump every two, but go backwards.
That is actually solid reasoning. Yeah. So yeah, that is the reason that doesn't
Also,
work.
pro tip, yeah, if you're when you're slicing, if you leave the indices blank, like if you just do colon, then
Also, you're
it'll just
muted.
like impute them. Yeah, I know. They can hear me now, if I'm right.
Can you guys hear Philip? Like
I
what?
can, so
Oh, you can?
yeah.
Okay, cool. Yeah.
That's why I keep pausing so much because I can hear the delay when I talk.
Uh yes, -2, -1 just returns back nuclear engineering. So I'll just go ahead and give the uh answer. So I want to start at index what 0, 1, 2, 3, right? My start index is 3. I do colon, and then my end index +1 would be 0, 1, 2, 3, 4. So it'd be 4 plus 1, that's 5. And that would go ahead and return me the last two elements as desired. Um, if you do want to use the I guess more succinct, that's the right word. Syntax. Um, Never mind. I don't know what I was doing there. But yeah, that's pretty much what it was. If I just Control Z. Yep, 325. So be careful when you're doing list slicing, because like just keep in mind like the general formula, the general syntax, and that will kind of guide you towards what you want to do. I also do want to demonstrate what the index jump does, just I guess for demonstration's sake.
Technically already did, but
Yeah, but just thoroughly. So if I want to access indices 1 through 4 like this, now let's say I want to I want to access every other element, so every second element. My step size will be 2, and look what that returns. That returns business analytics, skip this one, nuclear engineering, skip this one, then we've reached the end of first slice. And if I just increase that to 3, it returns business analytics, skip 1, skip 2, computer engineering, then you're at the end of the list. So that's just what step size kind of is talking about. Any questions about that so far? Okay, moving on then to NumPy. So NumPy arrays are just kind of a souped up version of lists or a high performance version of lists that are often used in machine learning data science. Data frames, which we're going to be talking about, I swear, by the end of today, are built on top of these. And these have inbuilt a lot of very useful scientific functions and numeric and mathematical operations that you can do with them. They're also like very foundational if you want to be doing stuff like linear algebra in Python as well. But yeah, so essentially, if you want to make a NumPy array, one option is to use this function np array and then pass in a normal Python list, and it will just shoot you back a NumPy array. Did I? Right. Okay. So in order to use NumPy is already preloaded into Colab, right?
Nope.
Nope.
Well, I mean, it exists. You need to like import it.
Okay, yeah, that's what I was. Okay. Yeah, so in order for you to use the NumPy, you have to import the library. So I'm gonna go ahead, import keyword NumPy, and since I want to rename it to something more convenient, I'm gonna say as NP. So whenever I use functions from the NumPy library, I'm just gonna say NP dot whatever function I want. So just to demonstrate the example that I just gave, let's say example array np dot arr or r I'm not a pirate. I don't know what I'm doing. I pass in the Python list one, so 1, 2, 3, and then just display out what that is. Oh, did I mess up this entire array? I'm stupid sometimes. Yeah, the function was array. I just redo that. Yep, now we have a NumPy array. So one of the key components about working with these is just knowing how dimensions work. And by that, I mean, like, how do you deal with 1D arrays, 2D arrays, 3D arrays, etc. So basically how it works is that 1D, you have these things called axes. So a 1D array will only have one axis, which is like called axis 0. That's obviously just going to correspond to the length of the actual array. So right here, axis 0, you can count up how many elements are in axis 0. 1, 2, 3, 4. That's just a length, right? So on top of that, there's an attribute associated with NumPy arrays. That's called your shape. And you can essentially think about that as the thing that indicates the dimensions of whatever NumPy array you're dealing with. So right here, since we only have one axis to deal with, shape is going to be parentheses 4 comma. It's only going to correspond to one axis. Axis. Yes. So for a 2D array, we actually going to have two axes right now. Axis 0 is going to correspond to, you can think of it as the number of rows in this 2D array, or if you want to visualize it as a matrix, that's also going to be counting the number of rows here. So here you can clearly see that if you count along axis 0, count how many rows there are 2 rows. So axis 0 corresponds to 2. And you can see that in the shape parameter here, we have 2 corresponding to axis 0. Now, axis 1 is going to correspond to the number of columns you have in the 2D array. And if I count along axis 1, 1, 2, 3, that's 3 columns right there. So axis 1 is going to be of dimension 3. So in total, your shape is going to be 2, 3. It's kind of like a 2 by 3 matrix, right? And then, this keeps on going on. If you have a 3D array, you have 3 axes, then you have the extra axis 2 that gets chopped up at the end. The shape parameter, you get the point. See here. Yeah, so this is just from the like the definition of what shape is. If you name a NumPy array and you do dot shape, it will return the dimension of that multi-dimension array. And that's pretty useful if you want to like see, for example, the number of rows you have in a data set or something like that, or number of columns, et cetera, et cetera. Yeah, so I'm just going to go ahead to the short little demonstration of this. So let's say I want a 2D array, 2D NumPy array. So first of all, I'm going to define a 2D a list here. And what that is, I'll just enter it in to make it more visible. So I have my first, you can think of this as your first row of your 2D NumPy array. And that's going to be a list 10, 1, 5. And then my second row is going to be 6, 4, 3. Again, this is just a 2D list of the two elements, and each element is a list themselves, right? And so I pass that into my np.array function that will make it a NumPy array as advertised before, right? So I just go ahead, execute that. Now I want to know what the dimension of this NumPy array will be. So in order to do that, I will do first, I'll give the name dot shape, and it will return for me the dimension of it. And this makes sense, right? Because first entry of the shape corresponds to axis 0, in which case this is going to correspond to the number of rows. We have 2 rows here, so that checks out number 2 here. And the second parameter of the shape dimension is going to correspond to the number of columns, right, along axis 1. And we have 1, 2, 3 columns here. So this makes sense. So if I want to access elements from this 2D NumPy array, if I go ahead and if I want to access the first row, then I just have to index it like I would with a normal Python list, the square brackets. So since I want the first row, I'm going to be doing first array, square brackets, 0. And that will go ahead and return me the first row right here, right? And if I want to access, let's say, the second element of the first row, it's kind of the same thing with Python list. You just put another square bracket, put the index of what you want in the inner list. So I want the second one, so that'll be index 1. And that returns me the second element of row 1, which is just the number 1. Right. So just another example here. If I have a NumPy array I'm defining here, right? 1 second here. Okay. Okay. Yeah, no. We are back. So if I want to define a second NumPy array like so, right here, what I'm doing here, it's another 2D list, except the only difference is that I'm only passing in 1 row. So if I go ahead and access the shape of this, it's going to spit out for me 1, because that corresponds to the number of rows. It makes sense. And 4, because that's the number of columns. We have 4, 3, 2, 1, 4 columns. That makes sense. But if I do the exact same thing and just pass in a 1D list, and I print out the shape, it's only going to be the shape is only going to be 4 comma, because in this case we're passing in a 1D list, whereas in this case we're technically passing in a 2D list. So whatever shape returns highly depends on what you defined up here in your parameters. So just keep that in mind. So like I said before, you can do there's a lot of built-in operations you can do with these NumPy arrays, and they're actually very optimized. They're built to be very optimized, so very high performance operations. So there are very small examples like this where you only have like, I don't know, 4 entries in a list. You won't really see the difference. But when we're dealing with like very large data sets, and when we're doing a bunch of complicated mathematical operations like 1,000 times over, that is where you're going to see the performance increase in NumPy arrays as compared to Python lists. So to give an example, you have a sum function, which if I pass on to my first array for my first NumPy array, let me just remind ourselves what first array looks like. Yeah, so it's this 2D array. It looks like this. So if we do sum, dot sum, it is going to add up all the elements and return sum, right? Now, if I want the sum across, wait, what will this return me? Interesting. So if I want the sum across a certain axis, you can give a parameter option called and specify the axis you want the sum to be across. So in this case, I want the sum to be across the rows, right? So when I do this, it's going to go ahead and look at the rows and basically add up all of the elements that are in one column. So for the first one, we have 16. That comes from 10 plus 6 because we're adding row 1 to row 2, just in the same column. Same thing for the other two entries. We have 5 that comes from adding 1 to 4, get 5. Then you get 8, you add 5. 3, you get the point. I can do the same exact thing, but with this the other axis 1, that will be adding across the columns. So I get 16 here from adding 10 plus 1 plus 5. That's across this one row, just across different columns. And I get 13 from 6 plus 4 plus 3, right? There's also another operation. You could take the mean across like the columns in this case. And then, yeah, that was going to be 16 divided by 3. And then this will be 13 divided by 3. So yeah, that's pretty much it for NumPy. That's just the very basics. If you want to learn more about it, there's always a NumPy documentation. Take a look at that. That's the best resource. Any questions? Anything so far? Okay, cool. If that's the case, I'm gonna pass the mic on to my buddy Philip here, who's gonna take you into the world of data science.
You're gonna keep screen sharing. Cool. Hello, everyone. Yes, Samra turned on his webcam so you guys can get to see me. Also, say hi to this idiot over here. Anyway, so as you disabled participant screen share.
What?
You disabled participant screen share.
Oh, let me
Congrats.
just undo that. Or I can just make it co-host.
Either works.
Or I'll make it a host.
Maybe don't do that. Okay, so with that in mind, this should work here. Right, so next question is, but what is data science, right? Like the whole point of this meeting is to try and teach you guys data science. So what is the point of data science in the first place? Well, it's a long form definition here, which basically says that data science, basically I'm just going to read it out. Data science is an interdisciplinary field that uses scientific methods, blah, 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 to extract or extrapolate knowledge and insights from data. Right. So essentially, data science is the study of trying to figure out some sort of trend, some sort of insight, some sort of, something that you can report from just a giant bunch of data. And so what does that mean? Basically, all it means is that you're given a database and you try and use it to structure the data and you try and then clean the data. And then you use some sort of statistical methods to pull out the analysis and, figure out what sort of trends are in your data, really just to figure out what you're looking at. Right. So ultimately, the whole goal of data science is, given essentially a giant wall of numbers, more or less, can I pick out any sort of trends and any sort of insight from this wall of numbers using statistics and other fun little algorithms and mathematical methods we know? So with that in mind, there's a bunch of different libraries that really work, or that work quite well for data science. In general, all of them are built on top of NumPy, as Samrat meant earlier, which is why if you ever take a class or are asked in an interview or something like that, these libraries are usually referred to as the NumPy stack because they're all built on top of NumPy effectively. But with that, there's 3 major libraries. We've gone over NumPy already. Then there's Matplotlib, which is essentially it's just designed to replicate the way that MATLAB plot things. So it's just a plotting library that helps you make graphs and stuff. And the one that we're going to be talking about most later today is pandas, which is essentially allows you to have like spreadsheets more or less in a nice way, in a nice Pythonic way. So with that in mind, before we move on to just talking about pandas itself, I will say that if you want to continue more with this field, it's honestly really helpful to look at the documentation for NumPy and Matplotlib. I will say that's helped me a lot personally in my job and stuff. So, you know, pandas is obviously useful, but like no having good solid knowledge of all three is generally important. The thing is we can't do a whole lecture on Matplotlib because there's way too many different things to even talk about and it becomes kind of unstructured. But with that in mind, on to pandas. So pandas centers around the idea of a structure called a series or a pandas series. And then when you put a bunch of pandas series together, you get what's called a data frame, which is like the main object that you think that most people think of when you're working with pandas. So a data frame is more or less a table with labeled columns and labeled rows. The row labels or numbers or whatever is called the index. And it's the row index here. And the column names they're just called the column names, actually. You can call them the column index, but it's the column names, right? Now, the difference between a series and a data frame, which is somewhat important when you're working with pandas, is that a series is essentially just one column. So because you already know that you're working with just one column, it doesn't have a column name necessarily. A series is the one-dimensional object, so it only has the index or the row names or whatever. And a data frame, and then a data frame, you add like column names to each that like label basically each series. So you can more or less think of a data frame as just a collection of named series, and each series has its index, and all of them share the same index ideally, but whatever. It's a table. Honestly, best way to think of it is it's a table with row numbers or row names and column names.
Spreadsheets.
Yeah, Excel spreadsheets also are a thing. I just don't like Excel. But Excel's fine. I just actually like using Python a lot better. But with that said, okay, so that's effectively a data frame, just a table. So data frames have a lot of different names, a lot of different methods. Here are some of the just interesting ones to see things about it. So data frame.head, because, okay, so often when you're working with data frames, for the purposes of like right now, they're probably going to be very small, but it is not atypical to have data frames with like millions of rows. I mean, would you say? I mean, you've definitely dealt with like millions of rows data frames, right, Samrat?
Yeah.
You can unmute and talk.
Yeah. Yeah.
Yeah. All right. Yeah. He's nodding. And personally, I've also dealt with data frames that have millions of rows as well. Very commonly, because I mean, if you think about it, like all of the banking transactions made in the year of 2022, right? Those will all be stored in a data frame often, and you'll have to like analyze them. That's gonna, I mean, how many people use, like, let's take a bank like Capital One that everyone at UMD apparently goes to. Like, how many different people do you think are making, withdrawals or deposits at Capital One? Like, probably millions of people over the course of 1 year. So it's all of those records are commonly held in like, a spreadsheet or some sort of file. And that file is going to be millions of rows. But if you wanted to get like a small summary, like you just want to see like the first 5 entries to ensure that you have the right data frame, you can use the .head method. And then it has a parameter n that tells you how many rows specifically to print out. Usually if you leave it empty, it'll just do 5 of them, which is fine for just like looking at the thing. And mostly what it's used for, .head and .tail does the opposite. Instead of doing the first 5, it'll do like the last, or first n, it'll do the last n rows. So it'll start counting from the bottom and go up. But in general, what you usually do when you call dataframe.head or dataframe.tail is you're trying to figure out like just what the format of your data frame is, right? You've just imported it, you've loaded it in, and now you want to see like, okay, what are these column names? What sort of like values are in each column, type of stuff. It's essentially just trying to figure out what you're doing with the data frame. Set index is one that allows you to change the index or row labels of the data frame. You can, I don't remember the syntax, look it up, honestly, but it helps you change the labels because sometimes you might want rows that are labeled like, 1, 2, 3. But if each row corresponds to, say, like a year, you might want to label them like 2009, 2010, 2011, 2012, so on and so forth, so that it makes more sense when you're calling them. And in cases like that, you're going to want to change the index from 012 to 2009, whatever, so on and so forth. Data frame.shape returns the it's the exact same as NumPy's shape thing. It returns the shape. It returns a tuple representing the dimensionality of the data frame. Note that data frame.shape will always only be 2 numbers because a data frame is exactly 2-dimensional, right? So like, you can't do more than that, right? You can't do more than 2 dimensions in a data frame, right?
Not as far as I'm aware.
Yeah, so it'll always be 2-dimensional. So it'll give you number of rows, number of columns, or the other way around. I don't remember which way, but that's what the shape is. It's effectively the same as NumPy. And then D types will tell you the data types of each column. So say I have a column of names that's like, Phil, Samrat, Ritik, Anirudh, so on and so forth. That's going to be like, a column of D type string, right? And then I have the next one, which is like, like, I don't know, high score on Flappy Bird or something. It's like 50, 12, 38. That's going to be a D-type float or int or however it reads it in. But it's going to have some sort of like numeric D-type. So all it does is essentially tells you the data type of each column. Note that if you have, you can have columns with mixed data types, right? So I can have a column that has strings and numbers in it. That's fine. The D-type, when you do data frame.dtypes, the data type returned is going to be object, because the superclass that holds both strings and integers is object, right? So now, quickly, we're going to go and look at a data frame so we can just go through all of those methods, right? So if I scroll down here, okay, cool. Yeah, you guys can see it. So if I scroll down here, I'm going to move all of this.
Can you zoom in?
Can I zoom in? Sure.
Better.
Cool. Right. So yeah, run it anyway. I'm going to run both of these whenever it feels like loading. And let's first do .head, right? So actually, let's also print, in this thing, let's print out the data frame itself. And so this tells you everything. But let's look at .head. So .head, as you can see, does the first 5 rows. So from 0 to 4, right? Again, I can give it like a number, let's say 3, and it's only going to do the first 3 rows. If I change this to .tail, it will do the last 3 rows, which you'll see over here. Set index, I'm not going to bother with right now. What methods are talked about here? Yeah, set index, I'm not going to bother with right now because not needed, because I don't really want to change the index right now. However, let's look then at shape, right? So data.shape, and this should return exactly 10 by 3, right? We have 10 rows and 3. This should be, ideally, it should be 2 string columns and then 1 integer column. And exactly, okay, well, strings are stored as objects, more or less. But something that is handy to note is that these D types actually somewhat change what you can do with each column, which we'll talk about slightly, which we'll go into more detail later, but I'm still going to start talking about it now anyway. So you can see if I have a column of integers, right? If I know that every single thing is an integer there, then I know that there's some things I might want to do with it. Like I could take the mean, right? So let's do like data. So you index, by the way, for reference, when you're accessing data frames, you index it the same way you do for like a dictionary. When you're trying to access like specific columns, you just do column name. So data category will return the category column. However, when you're trying to do the rows, you have to use the specific thing called .iloc, and then like whatever row number you want. What did I just do? Whatever. So iloc, and then you'll do like the row number. Now note that iloc means index location, so technically it's dependent on the index. So if I change the index to like strings, then I would index it by the string that I'm looking for. But honestly, most of the time you're indexing by column. So let's say for the calories, right? I want to calculate like the mean of all of these things. It's not really useful in this specific case, but let's do it, right? You do .mean, and it'll tell me, the mean of all these things, right? It's this big number. Thank you, outliers. But another thing is, okay, let's try this on an object column, right? Let's do a .mean thing. So let's do for category, let's try the .mean method. And you'll see it doesn't like it because you can't convert this thing to a numeric thing. Basically, what's happening on the back end is Pandas is looking at this column and it can add things, right? So how do we take the mean of something? You add a bunch of things together and then you divide by the total number, right? Well, first, I want to try and take the mean, add everything up. Well, Python has a nice way of adding strings. If you add two strings, it just concatenates them, right? So the adding part will work fine. But then what will happen is, specifically, you can read in the exception here, it has a check where it converts everything into a numeric type, right? Because it needs to be able to divide them, right? You can't divide strings. It doesn't really make sense, but you can divide numbers. So it tries to convert it into a float specifically, and then something breaks because it says, I can't convert this to a float. I don't know what to do. So that is somewhat important when you're, or that is really important actually when you're working with data frames, is to ensure that the data types of each column are as you expect. Because then later on, when you say that I have like a null value here and I list it as like an empty string per se, instead of like a not a number, like, you know, some sort of missing null value, if I list it as like an empty string, then when I try to do dot mean, you'll see it actually will fail because it's not, it doesn't have the type that's expecting. So how do I change this? Let's try this, right? Let's make this np.nan, which is numpy for not a number. I think this actually should still work. I don't know why I just ran an empty cell, but you know, we're going to pretend that I didn't do that. Yep. Oh, well, whoops, wrong column. Yep, it's okay. So that works because it's a not a number. But now let's try something fun. Let's change this to an empty string, right? And if you say, well, how many times am I going to get like a data frame that has like random entries with empty strings where there should be numbers? Every time, literally every time you load a data frame. Samra and I can both like concur on that time. There is never a case where I've loaded like a real world data frame and had it work like very nicely, perfectly out off the bat. There's always missing numbers because usually these come from like people recording things in spreadsheets and people are dumb. So you'll end up with a lot of just random values all over the place that really shouldn't be there. So you can see when I change this to a string here, right? The first issue is obviously data type has been changed to object. So already you know that some of the methods that we wanted to do won't work. But then specifically when I try to run mean, you'll see that there's an unsupported type for integer and string. Basically what happens is it goes through everything here and it's like, I can't add this empty string to all of the numbers here. So that's one thing that's very important when you're dealing with pandas is, or you want to check that whenever you're wondering like, okay, if I'm running like some sort of operation and it's not working, check the data types and try to see, oh, okay, well, you know, what's going on with this data frame? Is there some column that might be messed up? And if the column's messed up, then, you know where to go. So moving on from that whole thing, next thing is grouping or group by or whatever. And this is one major thing that you guys are going to be doing quite a bit with pandas data frames in general. What you're going to be doing effectively is when you do a group by, you're specifically trying to split the original data frame. You're trying to take subsets of the data frame. You're trying to just cut it up and be like, okay, well, say I want to group it by, like, you know, let's take the data frame that we have specifically here. Say I want to group it by category, right? I want to try and figure out which sort of, I want to try and figure out, like, I want to try and group it so that, like, there's one category for breakfast foods, one category for lunch food, so on and so forth. Well, specifically, the syntax is data.group by, and then this by parameter, you usually give it like a column name. And what this will return if I delete this dot count thing here, you'll notice this returns a group by object, right? What this means is that basically, I mean, it's all using like SQL or whatever under the hood, but what happens is that it just goes and it creates some sort of object that like stores everything in like a grouped format. But you need to call specific methods in order to actually access this. So let's do count, right? What count will do is it'll tell you in each column, right? How many foods have breakfast are under the breakfast category, or how many foods are under the dinner category, and so on and so forth. And so you can use that to try and figure out, certain counts here. Another thing that you can do with group by, I don't know if it'll work fully well because everything's kind of messed up. Yeah, you can take the mean, right? Now, naturally, pandas being nice, it omits the columns that you can't actually take the mean of, because it assumes that you didn't want to do that. So when I call group by mean, it's like, okay, well, you can't take the mean of strings, so we're just not going to bother about that. But what this will show you is, okay, given what's the mean amount of calories that like an average that, or what's the average amount of calories that you eat, say, when you're having breakfast, or average caloric intake, I guess, when you have breakfast. And you can see it'll give you back the numbers like this. Sometimes it'll give like even small numbers into scientific notation. Just don't worry about that. But you can see here that you have a lot of that. It gives you like the mean amount of calories per category type. And there are a bunch of other different methods that you can do on group by. The mean method is the one that I've used the most to try and get like summary statistics for like specific groups in your data set. Another one is also obviously count is useful. And aside from that, like, I don't know, Samrat, are there any others that you can think of, like group by dot whatever, that you use pretty often?
Mode.
Is mode a thing? I mean, I'd be surprised if it wasn't. No, it's not. All right, cool. Yeah, well, doesn't do that, but it does. Group by objects have a lot of different methods that you can try. Again, read the documentation for like a thorough like list of everything. But with that in mind, so essentially group by, it's, again, yeah, as I said earlier, it's the output of things. It's most useful when we're working together with aggregation functions, so summarizing the data like sum, mean, so on and so forth. So I guess next was an exercise, which I kind of already did technically. But you can see, like, we'll just walk through like a couple of different other things. So another one that you can do is the dot sum method on a group by object. So this time we want to group everything by the type of food that we're eating, or yeah, whatever food we're eating, and we want to take the sum of the total amount of calories for that specific one. And you'll see it returns this here, which means that, chicken corresponds to like a total calorie amount of like 1375. Honestly, it looks for everything that has a food type chicken, and then it just sums up all of the calorie numbers. Another thing that actually could mean something in this case, if you again take dot mean, would be, like average amount of calories that like chicken has, or average pancake, so on and so forth. And by doing that, you can calculate a lot of summary statistics with your data frame. What's another one that's like really helpful?
Could you show them how to, how we have the outlier pasta? Can you show them how to like get every row except for the last row?
Oh yeah, okay, yeah. And then like, actually no, I'll talk about row indexing. I'll talk about the indexes actually, because that one can be really confusing. And then I'll just close out on that. So notice that, okay, let's look at the data again, right? These columns are kind of redundant in a way, right? We've got a lot of like repeat things with pandas, or with food types, got a lot of repeats with calories, so on and so forth. Let's see if we can try and make a data frame. We can try and re-index the data frame, right? Let's say that we want to try and have different indices and index it by the food category, or by the category that we have here, right? Well, I believe, and also I'm probably going to mess this up because I don't do this too often, but it is a very useful thing, is if I set the index to data, someone tell me if I'm doing something terribly wrong.
Okay.
This should work. Yep. And now you can see, and then like, let's say I just dropped the category thing, because why not?
What does drop do, Philip?
Drop literally just removes the column. So I was going to go through that. Thanks. So when you do set index on like a thing, it'll basically remap the index numbers from like, 0, 1, 2, whatever, to, the column name. And then if I drop tells you to like remove the column with this label, axis equals 1, just forces it to look at columns. You can drop rows. And so if you drew like drop 0, axis equals 0, that'll drop like the first row. But more commonly you use it to like remove a column from your data frame if you determine that you don't need it anymore. So you can see when I run that, now everything's as the index of what category it's under, and then food. So now if as I mentioned earlier, if I want to do index location, all right, it's .iloc square brackets, and then I think if I just do breakfast, this could possibly break. It does not break. Okay, yeah, okay, so iloc is not index location, it's integer. But if I do .loc, that also doesn't work. How the heck do you do index? How did that work again?
What are you trying to do?
Just trying to index everything that has breakfast by using the index instead of. I know that iLock definitely works with numbers. So if I want to do iLock 0, that'll give me the first row.
Right.
And you can see it's got breakfast, whatever the heck. I don't know. I don't use the index changing too much, but you can do things like that. So like another thing is, I can pull up like actually, none of you are taking CMSC 471, I'd assume. So I can pull up like a recent project actually. File, open notebook. Where was that recent? Where was that? Huh? Did I not pull? Okay, right, I got it. See this. Yeah, cool. Right. So let's take my CMSC 471 project, right? Specifically, we wanted to look at some tuberculosis data, right? There was a case where I had a lot of things. You can see there's a lot of like missing numbers here. After a bit, through all of this, you can see there's a very specific place where what I did is I had to set one of the axes, and then I changed the index somewhere. Well, whatever. I did it by hand somehow. But the point is that like it's much more natural because each of these were like year by year by year. I indexed it by year instead of having to index it by number, because it makes more sense. Like, okay, I want to grab the row that corresponds to 2009. Well, I don't want to remember like which order I collected 2009 in. I just want to be like, okay, row 2009 and go for it from there. Specifically, .loc should work. So .loc is the same thing as iLoc, except instead of integer, it's just location. But should work. What do you mean? Oh, I didn't. Sorry. Whoops. I didn't change the data frame, so that'll actually do it. So let's rename this terrible variable name. We'll go with that. And then I want to just print the data frame again. And then once I've re-indexed it, if I try to index it by dinner, you can see it'll give me back this subcategory that has all of the dinner here with rice, food, whatever. I can change this to breakfast. And it'll give me stuff like that. So you can do a whole bunch of fun stuff with your index once you start changing things around. There's also ways I think you can set it to like have like multi-level indices. But I personally don't know too much about that, so I would say look it up. I know it's possible, but
Well, that was also a good demonstration of how like some operations and data frames by default are in place.
oh yeah, that's actually before I close out, I will make one comment on that, which is pandas kind of assumes that you don't want to do operations in place, meaning that when I call like data.setIndex, it doesn't change the data frame itself. It just returns a copy with the changes that I asked for in the function. There usually is like a parameter where you can say in place equals true, which means that you don't have to set it equal to something. But very often, because you don't want to like, accidentally mess up like the state of the data when you're working with Jupyter notebooks and stuff, it's kind of somewhat common practice to every time you make like a large amount of changes in one go, you kind of like change the name. So you can see again, I'll like use it like in actual examples here. The names aren't great, but like I loaded this thing as DF, and this is like the raw version, and then I changed it to raw TBDF, which is just all of the entries that correspond to tuberculosis. And then after this, it's called TBDF NAN, which does all the transformations I want, just remove the columns I wanted. And you can see it has a bunch of NANs in there where like, there were missing values. And then it ultimately becomes TBDF or tuberculosis data frame. When I like, there are still NANs in here, but like I imputed a couple, or added a couple numbers that I could just like calculate myself. And then this cleaned version was what I used to plot a bunch of graphs, which are very not complicated. And you can see they're literally just line plots. But point stands, very commonly after you do like a large amount of things, like each block, you kind of want to change the name, unless like that's the final version you're rolling with, because each time, in case like the changes cause issues, you want to be able to go back to the previous version and like not accidentally override things. Right. So with that in mind, I believe that's all for this meeting.
Do you wanna quickly show how to drop that outlier? It's pretty simple.
What do you mean by
The-
drop the outlier? Like,
yeah.
yeah, I can just drop the row, but is that what you mean? Or?
Yeah.
Oh, okay, yeah,
And then
cool.
take a minute.
Samrat's asking me to show you guys how to drop rows, because I already showed you how to drop columns. So reminder, so if I take the data, right, I have it like this. Say I want to drop the calories column, I would do drop calories axis equals 1. Axis equals 1 corresponds with drop a column and drop the column with labeled calories. You can see now the remaining data frame is the one without calories. If I want to drop a row, so let's see this last one, right? It has kind of an annoying, or this last row here has kind of an annoying outlier. Let's say, okay, I don't want to deal with that anymore. I know that it's in the last row. I just want to get rid of that last row. Well, same way with lists, where if I index list -1, it'll do the last element. I think if I just do drop -1 and then axis equals 0, it should. Ideally, it does not. Okay, it actually needs the row index number. So let me give it the index number, which is 9. And you can see now we have the data frame, but we do not have the last row in it. And so, yeah, that's effectively that. So, yeah, I would recommend looking through pandas to try and get like pandas documentation or pandas.org, whatever the website is, to get a full idea of all of the different methods for data frames. Because you can see we taught you a couple, but if I go to pandas document, you can see the amount of different things I've searched with this. I never remember it myself. But if I go through the documentation, you can see there are API reference, data frame. There are a lot of methods for data frames, and sometimes you'll just need some random ones out of here. So, you know, when you're, it's nice to like look through here and just play around with random things. Another thing is, specifically, there's a read whatever pandas. Where's the input output? Yeah. We didn't go over these, but you can read different types of files. Commonly, you'll get something like a CSV or comma separated variables, where it's just kind of like the default for like universal storage of tables. And you'll commonly read pandas object or data frames as CSVs. But you can read a bunch of things. So you can read like text files, you can read HTML pickle files, which is like a Python thing. You can read JSONs, HTML, if you're like reading a data table that you're pulling off of like a website or something. XML files, I haven't done that commonly, but I know it's possible. Did not know you could turn it into LaTeX. You can read H5s, again, not really common. Where is the big one? They don't have, huh? Oh yeah, there we are. Excel. Yeah, you can. Another thing is you can read Excel spreadsheets, and directly you just need to read the Excel. You just need to give it the file path, and obviously it'll load the Excel sheet as like a pandas data frame. In general, though, the most used one that I've used is read CSV, mostly because usually when you're trying to transport things around, you're saving things as CSVs and not like Excel specific formats or whatever. But with that in mind, I believe that's all that I have.